Welcome to Remote Learning 6th graders. This is our energy unit tutorial video. So today you will hear about potential and kinetic energy. Before we dive into that, just to review, everything in our universe is either matter or energy. We talked in our last unit that if something was matter, it had both mass and volume. Well, in this unit, we're looking at the other category, which is energy. Energy is the ability to cause change. So if something's not matter, then it must fit into this energy category. It must have the ability to cause change. All energy that we'll be talking about in this unit can be divided into one of two categories, either potential or kinetic energy, stored or moving energy. To give you a little introduction into what those two energies look like, I have a quick cartoon video.
Once upon a time, a very small man had to do battle with a very large giant. The only thing that the small man had going for him was his sling. When he let loose with it, the mass of the stone combined with its speed to give it kinetic energy with which it was able to do work on the giant, thereby applying force and exerting that force through a distance. The stone had energy thanks to its movement. Indeed, everything that moves has energy, even the air around us. Once air is moving, it has the energy to drive windmills. Just as when water is moving, it has the energy to drive water mills. But if every moving thing has kinetic energy, does that mean that things which aren't moving don't have energy? In that case, why are you staring up at that rock perched on the edge of the cliff? Why be frightened of it? It can't have any kinetic energy because it's not moving. And if it hasn't any kinetic energy, it can't do any work on you, can it? But maybe you'd better move out of the way all the same. Why? Because of the rock's position on the edge of the cliff. It hasn't any movement so far, but it looks as if it's on the point of having quite a lot of movement any minute now. Because the force of gravity wants very much to make it fall off the cliff. That means that in a sense, the rock has a lot of energy stored up in it. A lot of what scientists call potential energy, or the energy of position. The slightest puff of wind, and that potential energy will immediately start being transformed into kinetic energy. That's how the energy of position becomes the energy of movement. Uh-oh, don't look now. But it's time to use some more kinetic energy to do some more work on that giant. Whoops. Hold on. What's happening? Let's do that again in slow motion. The stone lost more and more speed as it left your sling because of the force of gravity trying to pull it down. The higher it got, the slower it went, and the less kinetic energy it had. Until at last it came to a complete stop and had no kinetic energy left in it at all. And therefore, no work in it, and no force that it could exert on the giant. But where did all that kinetic energy go? Is it lost forever? No. It's being transformed into potential energy. The work that the little man put into slinging the stone is now stored up in the stone. But of course, in reality, the stone only stops for a split second, and then immediately starts coming down again, until it has got back all the kinetic energy that it had in the first place. Meanwhile, back at the cliff edge, the giant finds all this very amusing, but he'd better watch out, because most of the kinetic energy it took for him to climb up to the top of the cliff is now stored in him by virtue of his position. He's full of potential energy, just waiting to be converted back into kinetic energy any minute now. Timber! Sắp chưa mở sư phải là
right, that was our video on potential and kinetic energy. Back to our tutorial. When we talk about potential energy, we are talking about the object's stored energy. This is not energy that's being used, but instead energy that's being stored. Potential energy is dependent on an object's position and condition, okay? Meaning where it's located and if it's new versus used. Some examples of objects that contain potential or stored energy that can be used later are batteries, gasoline, food, plants, and an acorn hanging on a tree. Potential energy. In order for things to have potential energy, it depends on their position and location. The higher up we move something, the more potential it has to move. A penny sitting on the top of a very high building, like the Empire State Building, has a lot more potential to fall and move than a rock that's already sitting safely on the ground. So the higher an object is, the more potential it has to move, therefore the more potential energy it has. Some common uses of potential energy would be energy that's being stored to allow things to run or work later. Gasoline has a lot of potential energy. It has lots of energy that can be converted and used into making cars run. Batteries help run our toys. So batteries store energy, and when you put those batteries into a toy, the toy works, moves, or runs. Food is also full of potential energy. The food that's sitting on your counter or in your fridge has the potential to make you move and work. And some forms of potential energy, which we'll circle back a little bit later to in the slideshow, would be chemical, nuclear, gravitational, and mechanical. The way to increase the potential energy in an object, the way to increase the potential an object has to move or work, is to place the object in a higher location. The farther up an object is, the more potential it has to fall or move. In addition, we can give an object more mass. The heavier it is, the more potential it has to move. On the left-hand side of your screen, you'll see two skiers. Both weigh the same amount, 500 newtons. The red skier is starting from a lower position than the blue skier. The blue skier will have more potential energy because he is starting from a higher location. On the right-hand side of your screen, you see two skiers. One weighs 500 newtons, the red one. One weighs 600 newtons, the green one. Both are starting at the same location, but the green skier, who has more mass, will have more potential energy. Of these two objects, which has more potential energy? The brick on the left or the feather on the right? Hopefully you said the brick. The brick is heavier than the feather, therefore it has more potential energy. Of these three objects, if we were to drop an object from the top, where would it have the most potential energy? A skyscraper, a chair, or a crane? Hopefully you said the skyscraper, which is the tallest object. So by dropping something from the top of a very tall object, we have given it more potential energy. Potential energy converts into kinetic energy when an object begins to move. When our stored potential energy begins to turn into moving energy, we call that kinetic. Kinetic energy is energy of motion. Moving energy or kinetic energy is dependent on an object's mass and the speed at which it's moving. If you want to give an object more kinetic energy, we can make it heavier or faster. Some examples of moving energy would be a person running, a bicycle wheel spinning, or a frisbee flying in the air. Kinetic energy is seen when objects are moving. Which one has more kinetic energy between a baseball and an airplane? Well, which one's moving faster? Hopefully you say the airplane. Some forms of kinetic energy, some forms of energy where we see movement would be sound waves, sound traveling or moving through the air. Solar or radiant energy, where the sun waves are traveling through the air. Electrical energy, where our electrons are moving to create lightning and electricity. And again, what they all have in common is they are moving energy. We see some sort of movement. To increase kinetic energy, we increase, again, how fast an object's moving or how heavy an object is. On the left of your screen, you see a bowling ball and a ping pong ball traveling down a lane. Which has more moving energy? Hopefully you say the bowling ball because it is heavier. And then on the right-hand side of your screen, you see two bowling balls of equal mass. One is moving a lot faster than the other, so it has greater kinetic energy. The purple is moving faster, more kinetic energy. Of these two objects, which are moving at the same speed, which will have more kinetic energy? Hopefully you say the semi. It weighs more, therefore it has more kinetic energy. Roller coasters are a great example of how kinetic and potential energy can transfer from one form to the next, how we can go from kinetic to potential, from potential to kinetic. Where does the car on this roller coaster have the most potential energy, the most stored energy? Remember, that's depending on position. So the most potential energy would be at the very top of the highest hill. The higher the car is lifted by the motor, the more potential energy is produced. At the top of the hill, the car has a huge amount of potential energy, but very little kinetic energy because it pauses and doesn't move for a minute before it barrels back down the backside of that hill. As the car accelerates down that hill, the potential energy is converted into kinetic energy until at the very bottom of the hill, there's little potential energy left and it's all moving kinetic energy. And again, put together like this, it looks like potential energy increases as the car goes up the hill. And then as the car begins to move down the hill, the potential energy becomes kinetic. As the car begins to creep up the second hill, the potential energy begins to increase and the kinetic energy begins to decrease. See if you can label the roller coaster with potential and kinetic energy. At point W, we have a high amount of potential energy. At point X, all of that potential energy has been converted into moving or kinetic energy. At point Y, again, we have potential energy. And at point Z, we have kinetic energy. An archer that draws a bowstring back to his cheek and waits to release has potential energy. A runner who is running throughout a trail has kinetic energy. A skateboarder who is doing some tricks has kinetic energy. A skateboarder who's standing at the top of a half pipe waiting to do his tricks has potential energy. Somebody standing with a book above their head has potential energy. A major league pitcher delivering a pitch, kinetic energy. The law of conservation of energy says just this: energy can only be transferred back and forth between form to form No new energy can be added to a system, nor do we lose energy that we had. Every time energy goes from potential to kinetic, it's there in the same amount, just in a different form. If we start with 100 newtons of potential energy, then that 100 newtons of potential can become 100 newtons of kinetic. We don't add or subtract energy from a system, it just gets transferred from one form to the next. And again, that's just another graphic that shows potential changing to kinetic, kinetic turning back to potential, and over and over and over again. Okay, the yo-yo is a perfect example. Starting with the yo-yo in your hand and dropping it toward the floor, we have potential that begins to convert to kinetic. At the bottom of the drop, it's all kinetic, and as it moves back up the string, the kinetic becomes potential again until the yo-yo rests in our hand where it has all potential and no kinetic. Energy can be transferred from potential to kinetic. If an object has more potential energy to begin with, it's going to have more kinetic energy when it starts moving. A pendulum shows that exact same concept. Just like the yo-yo, the higher back you pull the pendulum, the more potential energy you give the system, which means the more kinetic energy the object will have. Energy can also transform into forms other than potential and kinetic. It can transform into thermal or heat energy, like a toaster. It can transform into mechanical energy, like our body using food to move. And it can transform into electrical energy as well. Some different forms of energy. On the left-hand side of this graphic organizer, we see that under kinetic energy, some types of movement energy would be thermal, mechanical, electrical, and magnetic. On the right-hand side for potential, we see chemical, elastic, nuclear, and gravitational. And then right down the middle, where we see energy that could ping pong from one to the next, would be sound and light. If those waves are moving, then we have kinetic energy. If they are not, then they are potential. Changing forms of energy. We mentioned some of these earlier, but an automobile engine changes chemical energy into mechanical and heat. A tree changes the sun's radiant energy into chemical energy for food. Hammering a nail changes mechanical energy to deformation and heat. A thermonuclear reaction changes nuclear energy to radiant and heat energy. An electric mixer changes electrical energy to mechanical and heat. Types of energy. Click here to watch a short video. So just to review those types, we have a quick video.
Today, with the power of simple machines, we're gonna make a mess!
Welcome to Moo Math and Science. In this video, I'd like to talk about different forms of energy. Up first is mechanical energy. As this roller coaster moves up this hill, energy is used to overcome the force of gravity. You lose energy, but the roller coaster gains potential energy. At the top of the hill, the coaster has potential energy. As the coaster moves down the hill, it now has kinetic energy, or energy of movement. So mechanical energy is the total of the potential energy plus the kinetic energy. Nuclear energy is energy stored in the nucleus of an atom. When large atoms such as uranium or plutonium are split into two smaller atoms, in a process called fission, energy is released. Nuclear power plants use this process to help create energy. Chemical energy is the energy of chemical reactions. Chemical energy of a chemical substance can be transformed to other forms of energy by a chemical reaction. A chemical reaction is one chemical substance is transformed into another. Examples of chemical energy include batteries, burning gas in a car, and fireworks. Light energy is a form of electromagnetic radiation which means it has electric fields and magnetic fields vibrating back and forth very quickly as a wave. Visible light is the portion of this radiant energy that we can see. Examples of light energy include light bulbs, a fire, or a lamp. Sound energy is the form of energy that is associated with vibrations of matter. It is a type of wave, which means it needs an object to travel through like air or water. When you play a guitar, the strings vibrate and cause waves to travel to your ear. And finally, electrical energy is the energy that is caused by moving electric ions. Since the electric charges are moving, this is a form of kinetic energy. The faster the electric charges are moving, the more electrical energy they carry. Electrical energy powers most of the appliances and gadgets in your house. So there we go, several different types of energy. Thanks for watching, and Moo Math uploads a new math and science video every day. Please subscribe.
So just an introduction to some different types of energy. Energy transformations, again, is just a fancy way to show that energy can move from one form to the next. So chemical energy from food can be transferred into the energy that allows us to move. Energy from the sun can be used by trees for food. Energy that's stored in gasoline can be transferred into moving energy in a car, and electrical energy can be transferred into heat energy. Lava lamp is one example of energy transformations. We have kinetic energy with the light and heat at the bottom of a lava lamp. And then we have some of that energy be transformed into just heat, just light, and even some moving energy, all which is from the kinetic electrical energy that is fueling the lava lamp. Thanks for watching. I hope this helped. I will also link in just the slideshow if you need to go back and review any of those slides independently.